Star coordinates is an important visualization method able to reveal patterns and groups from multi-dimensional data, while still showing the impact of data attributes in the formation of such patterns and groups. Despite its usefulness, star coordinates bears limitations that impair its use in several scenarios. For instance, when the number of data dimensions is high, the resulting visualization becomes cluttered, hampering the joint analysis of attribute importance and group or pattern formation. In this work we proposed a novel methodology that makes star coordinates a feasible alternative to analyze high-dimensional data. The proposed method relies on a clustering mechanism to group attributes so as to mitigate visual clutter. Clustering can be performed automatically as well as interactively using some interactive operations like scale for calibration, the contribution of dimension in the layout, rotation for modifies the direction of dimension contribution, union for grouped attribute axes and combined contributions, separation for split clusters of attributes axes and incorporate individual contributions, removal for remove axes and disregarding their influence, reinsertion for reinsert removed dimensions, position tuning for automated mechanism to arrange attribute axes in the visual space, and some complements like node preview for magnifies a clustered axis as a local star coordinates visualization. Quality analyzer for provides information about the quality of the layout during user interaction. And node explorer for local visual interaction, allowing users to further analyze the impact of attributes on the radial layout, thus assisting users in the understand of the data and its attributes. The effectiveness of our approach is shown through a set of experiments and case studies, which attest usefulness of the proposed method. The first case study handles a data set containing the performance of 462 National Basketball Association players during 2009 to 2010 season. Each data instances with 36 attributes which describe statistics about players, on and off court, and information related to teammates and opponents. Among some of the most relevant attributes are, points scored by the player or team, number of possessions, offensive and defensive, number of rebounds by the player and team, number of minutes played by the player. The initial 36 attribute axis visualization gives rise to a linearly spread layout that does not reveal any prominent cluster of pattern. In the initial configuration, length and position of the attribute axes are uniform. The image shows the layout resulting from applying iStar's attribute clustering and reordering. Clustering has been computed with the PCA-based scheme with 6 axes, and the attribute axes were arranged using the similarity mechanism. Notice that 3 clusters show up in the layout, the larger one placed in the center, and the other 2 the above part of the layout. Most attributes have been grouped into the purple axis, indicating they are correlated. The next step illustrates some interactive resources in action. For instance, some attributes were interactively moved from one cluster to another. Scaling and rotation operations were also interactively performed to better discriminate the 3 clusters. The zoomed disks show Node Explorer widget depicting the content of clustered axis. We highlight 2 clusters with relevant information to be reported. In the dark purple disk, the groups of players are located near the center of the layout, meaning poor performance as to a cumulative number of offensive rebounds and the relevance of the player for his team on game. In the light purple disk we see that some players are isolated from the rest, revealing that the top attribute is very relevant for that cluster. More precisely, the attribute says that this player's performed a considerably number of rebounds for his team when those players were on court, but a lower number of accumulative rebounds for themselves since individual attribute rate of defense rebounds has not strongly influenced in their position in the layout. The light green disk magnifies attributes related to off-court. The players in question are now located on the top right part of the layout. It is easy to see that the players in this group have large value for this attributes, that meaning long periods and possessions when the player was off-court. Therefore, those players presented a good performance with very little contribution for their teams during the season. Among the players in the question group we find famous players. such as Ming Yao, who did not play the entire season because he was retiring. And Blake Griffin, who had been selected from the draft 2009 but he missed the entire season due to surgery.